Machine Learning, a Practitioner's Approach Lecture Number 3, Reasoning by Knowledge. This chapter discusses the reasoning methods for knowledge and its representations. Data represents unorganized and unprocessed facts and figures. Usually data is static in nature with a set of discrete facts about events. It simply exists and has no significance beyond its existence. Information is processed data. Data that has been interpreted so that it has meaning for the user. Information can be considered as an aggregation of data which makes decision-making easier. Knowledge is human understanding of a subject matter that has been acquired through proper study and experiences. Knowledge is usually built by learning, thinking and proper understanding of the problem area. It can be considered as the integration of human perceptive process that helps them to draw meaningful conclusion. Wisdom is the ability of human being to judge between right and wrong or good and bad. Wisdom is an understanding and realizing of people, things, events or situations, resulting in the capability to choose or find an alternative to constantly create the best results within a minimum time. Knowledge is defined as expertise and skills acquired by a person through experience or education, the theoretical or practical understanding of a subject. The kind of knowledge which needs to be represented in artificial intelligence systems are objects, events, performance, meta-knowledge, facts and knowledge base. The objects are facts in a domain of real world. For example, a car has wheels. The actions which occur in our world are events. For example, drive a car. Knowledge about how to do things is understood from performance. For example, good mileage for the car. Meta-knowledge is knowledge about a pre-selected knowledge or what we know. For example, Jimny is an upcoming car from Suzuki. The truth about real-world representation is called as facts. For example, Rolls-Royce is a luxurious car. Knowledge management is a set of strategies and practices used in an organization to identify, create and represent, distribute and enable adoption of insights and experience. Knowledge management emerged as a scientific discipline in 1990s. Knowledge management is desirable to address this question after developing some concepts regarding knowledge. Symbolic representation is a discrete unit expressed in formal languages. Subsymbolic representation cannot be the single symbols stored in a form of information. The hybrid systems involving both types of knowledge representation. Declarative representation of knowledge are facts like objects and events that we have to observe in the environment. For example, I am a human or the sun shining. The procedural knowledge represents the skills or rules we use to operate with and reason using facts. For example, if John is a human then John has 2 legs. It is the simplest way of storing facts which uses the relational method, and each fact about a set of the object is set out systematically in columns. This approach of knowledge representation is famous in database systems where the relationship between different entities is represented. Contents of knowledge base is part of cognitive model and some models hypothesize multiple knowledge bases. A knowledge base is a type of database for knowledge management. The knowledge base contains means for information to be collected, organized, shared, searched and utilized. The knowledge base has facts, rules and its connected relations. There are general facts which are known to all. Such facts are stored in knowledge base. The facts and rules are stated in a formal language by which it can connect each other when problem-solving encounters. This is generally some form of predicate calculus. For a practical side, in order to perform their desired tasks, medical experts require access to knowledge about their domains. Figure shows an example of relationship, facts and representation schemes with respect to knowledge base. There are mainly 2 types of knowledge base that are essentially closed or open information repositories. Machine-readable knowledge bases and human-readable knowledge bases are these 2. Data is the primitive verifiable facts of any representation. Data reflects current world, often voluminous, frequently changing, and information is the interpreted data. Knowledge is relation among sets of data and information that is very often used for further information deduction. Knowledge is general, not like data, and contains information about behavior of abstract models of the world. Knowledge classification is based on source orientation and types. According to source, there are empirical and theoretical approach. According to orientation, there are domain, heuristic and inference methods. According to type, there are declarative and procedural methods. A logic is a formal language with precisely defined syntax and semantics, which supports sound inference and independent of domain of application. First-order logic is a collection of formal systems used in computer science, mathematics, philosophy, and linguistics. First-order logic is one of the knowledge representation methods in artificial intelligence. It is an extension to propositional logic which communicates to represent the natural language statements in a short way. Propositional calculus is a branch of logic. It is also called propositional logic, statement logic, sentential calculus, sentential logic, or sometimes zeroth-order logic. It deals with propositions and argument flow. Compound propositions are formed by connecting propositions by logical connectives. John is my friend. Here John is the subject and is my friend is the predicate. Consider two facts as follows. P represents the fact John likes chocolate. Q represents the fact John has chocolate. The components of an expression are predicate, symbols, objects, variable symbols, function symbols, and constant symbols. Statements or sentences in the language are constructed from atomic propositions and logical connectives. Sentences in propositional logic tell you about what is true or false. It is a very general system of logic which accurately expresses a huge variety of assertions and modes of reasoning. Any sentence in a language is explained with syntax and semantics. To explain syntax, we need to look the legitimate expressions. The legitimate expression in predicate calculus is known as well-formed formula. We can define inference rules, which are guaranteed to give true conclusions given true premises. Consider two sentences. Each sentence is mapped into P and Q. P is it is raining and Q is I carry my umbrella. If P implies Q then Q, which mean I carry my umbrella. More complex rules of inference are given. Similarly, more complex inference is given here. Propositional logic isn't powerful enough as a general knowledge representation language. An example is given. In predicate logic, the basic unit is a predicate or argument structure called an atomic sentence. Some of the examples are given here. Some of the examples for predicate forms are given here. First-order logic contains two standard quantifiers, called universal and existential. Universal quantification corresponds to conjunction. Universal quantifiers are usually formed if-then rules by using implies symbol. Existential quantification corresponds to disjunction. Existential quantifiers are usually used with and to specify a list of properties or facts about an individual. Connectives are and, or, not, implication and if. Another example, consider the following sentences. Convert these sentences into well-formed formulae. There is a precise meaning to expressions in predicate logic. Like in propositional logic, it is all about determining whether something is true or false. Again, we can define inference rules allowing us to say that if certain things are true, certain other things are sure to be true. In predicates, the coefficient having connective quantifiers, true and false values form the basis of predicate calculus. Sentences are built up from terms and atoms. Fuzzy logic is a different approach to representing uncertainty in problem solving. Fuzzy logic focuses on describing events' ambiguities rather than the uncertainty about the occurrence of an event. Modification of the definitions of set theory and logic results in the fuzzy set theory. Traditional set theory defines set memberships as a Boolean predicate. In the usual set theory, an object is a member of a set or is not a member of the set. Traditional logics are based on the notion that PA is true if A is member of the set, otherwise PA is false. There is no parallel containment. This amounts to the use of a characteristics function for set A. Resolution by verification requires set of well-formed formulae be converted to clause forms, but a clause form may not exactly be resolving with clause forms may not give an answer which is required by the problem. So, one can deal with the well-formed formulae themselves and adopt methods of a given system called a rule-based system. In rule-based system, we have a set of fact and rules and a jail sentence. A set of rules forms a rule base and each rule can be used to produce a new fact from one or more established facts. The rule-based system represents knowledge in terms of a group of rules give a different situation. A rule-based system that consists of if-then rules, a group of facts and some interpreter controlling the application of the rules, given the facts. In backward chaining we start with the goal sentence, and the base rules are arrived at the given facts, whereas in forward chaining we start with the facts given in rule-based system to obtain goal sentence. Backward chaining architecture means that no rules are fired upon assertion of new knowledge. Consider this example for backward reasoning. If there are a cat and a dog, the cat is not afraid the dog. Solve the problem by backward reasoning. The solution is given in figure. In forward reasoning we obtain a sequence of assertions as inferences and two sentences are resolved. Forward chaining implies that upon assertion of new knowledge, all relevant inductive and deductive rules are fired exhaustively, effectively making all knowledge about the current state explicit within the state. Forward chaining may be regarded as progress from a known state or the original knowledge towards the goal states. Consider the facts and rules. Solve the following problem by forward chaining. The goal is to prove that there exists someone who is not a bulldog or who is noisy. The forward chaining is shown in figure. Case-based reasoning or Cbr, as the name implies, is a reasoning based on cases. We may define Cbr as the process of problem solving where the results are based on the solution of previous similar problems. For finding solution to a problem, solutions that were opted for similar cases in the past are retrieved. It is then used as a baseline for solving the present problem. The solution derived will be tested and retained. Case-based reasoning is a particular technique used for the development of a knowledge-based system. Cbr compares a current situation, or case, with situations that have been encountered in the past to see if one or more of the earlier situations can provide a model for how to act in the current situation. For example, the multiplication of 12 by 13. Cbr is well accepted in many cases because we can create solution from some background knowledge rather than from scratch. The users of Cbr are lawyers, doctors, engineers, etc. The case base can be easily termed as a database of cases. A case is a contextualized piece of knowledge representing an experience. A case contains the past lesson, that is the content of the case, and context in which the lesson can be used. Typically for the Cbr, the components are given here. Case-based reasoning can trace its roots to the field of psychology and theories about how human memory works. The case-based reasoning is shown in figure. There should be some method in which the cases need to be stored for easy retrieval. Most commonly used method is indexing. The indexing always needs to be predictive and must be concrete enough to be recognized in future. The cases are normally stored in a dynamic memory model, which helps to find the cases easily. When the match is found out, the system tries to use the same solution that is retrieved for this current problem too. The major task in Cbr is to refine the result. As case-based reasoning suggests only the solution of previous matches, it is a hard task in validating the result. The correctness can be found out by applying the revisited solution in a real environment or in some simulation. Retaining is the process of storing or incorporating valuable knowledge that we have framed for future reuse. This is the final step in the Cbr cycle. It can be considered as the feedback session where the system stores data according to the degree of success. The evolution of Cbr is discussing here. These are the key features of the Cbr system. If we see the practical point of view, the Cbr is worked on situation-based. The cases are obtained on experience-based. Cases are covered situations which evolve over time or represent a snapshot at a particular moment. By combining both, cases are obtained. The uses like doctor, architect or judge did not simply depend on one situation. They have to refer cases under similar conditions and future outcome can be used again. Several features describing a problem by the case users plus an outcome or a solution. The ingredients of case are text, numbers, symbols, multimedia. Cases are records of real events and are excellent for justifying decisions. A case is a contextualized piece of knowledge representing an experience that teaches a lesson fundamental to achieving the goals of the reasoned. Case library should have as complete a set of examples as possible by start with a small subset and reached into solutions or outcomes. This is how case represented. Depend upon the domain, the cases can be represented differently. Cases can range from flat lists of features to reasoning processes using object orientation, semantic networks, or neural networks. Components of a case are description of the problem, description of the solution or outcome. The problem description has two types. Ones that are important in retrieval and ones that are not important in retrieval. Solution is the stated or derived to the problem specified in the problem description. The resulting state of the world when the solution was carried out is the outcome. There are many advantages while using the Cbr for knowledge discovery. This is because it is derived from experiences. We need to keep in mind the various issues Cbr can get through if a proper scheme is not being employed. The practical issues are given here. The databases and Cbr are different. Cbr support fuzzy queries and offers rich indexing support. Cbr uses the known solutions to past experiences for solving a new problem whose solution is unknown. Cbr combines the benefits of information retrieval and rule-based reasoning. By comparing Cbr and rule-based systems, you may see these differences. The system becomes static unless new rules are added. It doesn't learn from new problems. While question and answer structure of RBS is restrictive. There are some disadvantages while using Cbr. They are given here. There is a wide range of applications where Cbr is being employed. In the case of medical field, Cbr is most commonly used for diagnosis. For diagnosis, the system will try to retrieve a past case with the same symptom and nature. In financial market also, Cbr is used to determine the values of variables by comparing with something similar. In applications of decision making and for creating new designs in architecture and industrial setup, we always check for similar cases. This reasoning refers to an inference method used in expert systems. Basically, model-based reasoning uses a model of the physical world. The main focus of application development is creating a model with observed data to derive conclusions such as a diagnosis or a prediction. The model-based reasoning schematic is shown in figure. You may please check the case studies discussed in this chapter. The case studies are elephants identification and retail analysis. Please check the exercises for your self-improvements.